Hello, it's Stephen Neshiba again, and I'm here to help you out with the third part of this computational exercise. And here's my cartoon again. Now, the third part, presuming that we've done all the rest of this through the buffer region and the initial pH, now we are at the end of the titration, and we're looking to find out what the pH is after we've added 30 mils of titrant, the sodium hydroxide. And just to remind you, then we're just gonna want to add in here the 30th, the concentration at this, that is the pH at this last point. Okay, and so how are we going to do that? Well, I've set up an ice table now for the analyte at the last bit of this, and as you can see, I've got A minus. We've got mostly A minus now. That's the predominant form, but it will undergo a little bit of association to produce HA and OH minus. So that's what we're going to try to pick up. So in order to do this, I'll need a few extra numbers. One of them is Kb of A minus is related to Ka of HA, and I think you know how to do that. That's just Kw divided by Ka if you want to give that a shot. Okay, I think I need to say here Kb is equal to 1 times 10 to the minus 14 divided by Ka. So there's that number. Now the second one is, this is the part that's a little bit tricky. The concentration of A minus in the analyte solution is, let me pick up that, in the analyte solution right there. I haven't drawn it, but now there's more volume in that analyte solution because we've added 30 mils of sodium hydroxide. So if you want to give that a try. All right, I think what I need to do is I need to say that that is going to be equal to, the concentration will be the number of moles of A minus, which is what this initial amount of HA was, which has all been converted to A minus, divided by the total volume. Well, that's the volume of HA that I started out with, 25 mils, plus the however many mils it took to titrate, 30 mils. Okay, so that's should be the concentration of A minus in that analyte solution. And let's see, now I can use that to start my ice table if you want to go ahead and give that a shot. Okay, here's my first number. I'm going to say the concentration of A minus is that number that we just got. And I'll say that it's I don't have any HA or any OH minus. And let's see, well, if you want to go ahead and try to finish this, go ahead. All right, I think what I need to do is to say that the change is going to be equal to however amount of X that we that reacts. And let's see, this is the same sort of thing. That's going to be plus X. And this one also will be equal to plus X. Okay, and if now the equilibrium value, I'm going to do that same sum thing that I did last time, sum of those two quantities, and drag that over. Okay, and now you know what to put in for QB, if you like. Why don't you give that a shot? Okay, here's what I think I should do. I think I should say QB is going to be equal to the products of the base association. That would be that number, the HA times the OH minus divided by the A minus. All right, so that's QB, and of course I get 0 for that. And now I'm ready for a goal seek because I want that QB to be equal to the equilibrium constant, 1 times 10 to the minus 9, if you want to give that a shot. Okay, I think I'm going to go to Tools, Goal Seek. And don't forget to set your precision parameter on this if you're doing this off VDesk. Let's see, I'm going to set cell E7 to, what's that value, 1 times 10 to the minus 9. Of course, it'll be different for you, but because you have a different acid dissociation constant. And how am I going to change that? Well, I'm going to change cell E6. Let's see if that gets me where I want to be. Well, this is looking okay to me. I've got a QB of 9 times 10 to the pretty close. It's not exactly perfect here, but it's fairly close. And let's see, then the pH would have to be equal to the negative of the log of the OH minus, if you want to give that a shot. All right, I think I should say minus log of the OH minus. That's the POH. And then the pH, of course, will be equal to 14 minus that, if you want to give that a shot. All right, that's going to be equal to 14 minus the pOH. So it looks like my final pH is 8.8, which I would maybe want to refine that a little bit in GoalSeek, but it's looking pretty good to me. The last pH is 8.85, and so I'm going to go down here and say at a volume of 30, I get a pH of 8.85. Okay, now, well, we're pretty much done. Now I think all I need to do, or you need to do, is make a graph. I've set up the volume and the pH right next to each other so that I can do that. And so may as well make a graph of that. You'll want to maybe annotate it a little bit better than I am, but a marked straight scatter looks pretty good to me. And there we have that.